In this video we're going to talk about quadratics, and the first thing we have to talk about when talking about quadratics is completing a square. So let's look at this expression we have here, and I want to expand it and simplify and see what happens. So this equals, when we expand this piece right here, when we expand an expression like that, we square the first term, get x squared. We multiply them together and double it, so we get plus 2 times bx over 2, and then square the last term, plus b squared over 4. And if that was too quick for you, do the FOIL method, first times the first, outside, inside, last, and you'll see that this is going to be what you get. And then we have this minus this term here, so it's minus b squared over 4. And simplifying, I get x squared plus 2's cancel, x squared plus bx. And b squared over 4 minus b squared over 4 is 0. So in the end here, what we're getting is the x squared plus bx equals x plus b over 2 squared minus b over 2 squared. Okay? And that's our little formula, and we just proved it in a couple of lines there. That is what we need to know when completing the square. Okay? Let's look at an example here. Write the expression x squared plus 6x in the form x plus t squared plus r. So x squared plus 6x equals, now if we go back and look at this formula, we'll see it's x squared plus bx. So what is our b here? So what's b going to be? Here's b. Okay? So it's x plus b over 2 squared minus b over 2 squared. So it'll be x plus b over 2, that sum squared, minus b over 2 squared. Our b is 6, so 6 divided by 2 is 3, so it will be x plus 3 squared minus b over 2 is b over 2 is 3 here, and when we square it we get 9, minus 9. So what this does is it gives me x squared plus 6, which is not a perfect square. It allows me to write it as a perfect square here, as x, the perfect square, x plus 3 squared, and then I have to take account for it actually wasn't a perfect square in the first place. I actually had to add 9 to it, and so I have to subtract 9 on the end here. Okay. Let's do another one. Let's do x squared. Let me go in a different color. Let's go with about x squared minus 6x. Well, again, so what's b going to be here? So you have to think of this as x squared plus a negative 6x. So my b is a negative 6. So this is going to equal x plus b over 2, so it's going to be x minus 3 squared minus, and b over 2, that's going to be a negative 3, but we're going to square it, and that's going to give me a positive 9, so but that negative is still left alone, so it's going to be minus 9. So, okay, so let's move on to the next one here. Suppose f of x equals x squared plus 6x plus 11. Find the vertex. So let me show you how to find the vertex on one of these. Let's stay in magenta there, I think it's pretty. So f of x equals, and so what you have to do is complete the square on this term right here, on the x squared plus 6x, the x squared plus bx, whatever that is. So that's going to be x plus, my b is 6, so b over 2 is 3, minus b over 2 squared, so minus 9 plus 11. So this is f of x equals x plus 3 squared plus 2. Okay, and so my vertex is going to be located at the x lies to you there, so that's going to be a negative 3 and 2. Okay, and from our transformation of functions is where we get that. So let me just sketch a quick graph here. So x squared does this number. Okay, that's going to be x squared, and so inside here, when I add 3, that moves it to the right. Moves it to the left 3 places. That moves my 0 to the left. 1, 2, 3. When I add 2, that bumps it up. Add 2 on them, that bumps it up 2 places. So there would be my vertex. Suppose f of x equals x squared plus 6x plus 11. Sketch the graph of f of x on an interval of length 4 centered at the vertex. So let's do that. I'm not going to make it all straight line. I'm just going to be sloppy here. So let's say we're here. And so my vertex was where? Negative 3, 2, negative 1, 2, 3, f1, 2. And so I go over. So now this is taking care of everything. All I need to know is that this thing behaves like x squared. It's just been scooted over 3 and scooted up 2. So now it behaves just like my regular x squared. And that's up. Let's see it go over 1, 2, up there. I don't know if I'm going to have room to do it. 1, 2, up 1, 2, 3, 4. That's the regular x squared. And this 6x plus 11, all that did was scoot it to the left 3 and up 2. So now this thing looks like, so I go over 1, up 1, I go over 2, up 1, 2, 3, 4, up in here somewhere, over 1, up 1, over 1, 2, up 1, 2, 3, 4, up in there somewhere, and we sketch the graph. Okay, so that is the graph of this function x squared plus 6x plus 11, and it's on an interval of length 4. That is 1, 2, and here I went over 1, 2. So that is my interval here is of length 1. Let me see. 1, 2, 3, 4, centered at the vertex right here. Okay, and that's going to conclude this video on quadratics.